we're going to take a look at the notes for quadratic roots, the factored form, and the discriminant. So the notes, you can either again write them in or put them in your notebook. But when we talk about quadratic roots, we're really talking about a part of the parabola that is crossing the x-axis, and specifically it's the locations where it crosses the x-axis. So these are sometimes referred to as zeros or solutions, or sometimes they're just referred to the x-intercepts. So when we think about the x-intercepts, or the roots or the zeros, you could have a couple of different possibilities when it comes to parabolas. You could have it cross at two locations. You could have it cross at one location, like here, or you could have it cross at none on the x-axis at all. So it is possible to have just because it's a parabola doesn't mean it's going to cross at the same amount, but it really is only one of those three possibilities. So when we look at those, we'll look a little bit at a different form of the equation that might help us identify these solutions, and then also it will give us, we'll also look at a sort of a formula called the discriminant that will give us a way to tell very quickly what type of solutions we have. So as we look at the three examples, we're going to look at just, how do we graph them normally, and we could use the axis of symmetry and then plug them in and find the vertex and find a table of values for that, and we could certainly graph that. And what we're looking for on the parabola is we're looking for, again, how many points does it cross. And so here you can see that it crosses in two locations. We can actually see what those locations are at -5 and +1, but it's also a good idea for us. We're going to explore at least taking this equation that is in standard form, and we're going to take and use that concept of factoring to transform it into a different form of the equation. So remember, with factoring, the idea is to take that trinomial and to break it down into two. So you can see here that we have, if we factor this and give us the value -5, but adds together to give you +4, that's going to be +5 and -1. And if you look at the factored form, notice that the x plus 5 is similar to vertex form in that it is 5 to the left. That's where it crosses. So at -5, and then x minus 1 is 1 to the right. That's where it crosses. And so you can see that the factored form actually gives us some clues to where the x-intercepts are. So if we look at the next example, we're going to again just graph it the way we normally would with the axis of symmetry and the vertex, and you can see that our vertex is 1, 0, and here's an indication where it is the vertex is directly on the x-axis. And so then if we go ahead and if we take a look at the factored form here and we factor it, notice that the factors actually end up being the same, x minus 1 and x minus 1. And in a lot of times in mathematics, we wouldn't write it as two separate terms. If they're the same, we would just write them in exponent form, which is x minus 1 squared. And notice that that is identical to vertex form. So again, but notice that these two factors are the same, and again, it's x minus 1. So we're going to do the third example then, and again, if we graph this, notice that the axis of symmetry is 1, and this value is this parabola is going to be opening down, and notice that in this case it doesn't cross the x-axis at all. So here's an example of one of those that has 0 solutions. Now if we try to factor this, notice that first of all its leading coefficient is -1. Might be a good idea to factor out that -1 first. It's just much easier to factor that way. And so if you try to factor x squared minus 2x plus 3, what you'll find out is that there's actually no combinations that will do that, and so this is actually not factorable. But just because an equation is not factorable doesn't mean that it always has zero solutions. There's actually other instances. If it's, for instance, it crosses at a location where it's not a fraction or a whole number. It's maybe a decimal that goes on forever. Those are going to be situations where they're not factorable. So just keep in mind, just because you can't factor something doesn't mean that it doesn't actually cross the x-axis or has a root. And we'll talk a little bit more about that later. So when we look at the solutions, for example 1, remember we said that it crossed the x-axis at -5 and 1, and again we'll just use the little brace symbols or the squiggly lines there to indicate that these are two separate solutions. You could write it as x equals 5 and x equals 1, and then for the second one it's going to be just 1. And notice for the no solution you can either leave it blank or you can use this symbol which is an empty set. That's also the way you can do that, or you can just write no roots. So the factored form that we're seeing here with this, so we'll see that the factored form, or sometimes we refer to it as the x-intercept form, is really this x minus a and times x minus b, and where a and b are the roots. Or if you think of it this way, A0 and B0 are the x-intercepts. And again, if we can put the standard form into this factored form, we get not only where the x-intercepts are, but this will also give us other clues to where the axes of symmetry are and where the vertex are as well. So in examples 4, 5, and 6, we're going to again just with the first one we'll just graph again the axis of symmetry, and we'll then take a look at the table. But before we graph it, let's see if we can factor this. And if we can factor it, and if we take and go ahead and factor 16 and -10, you'll notice that that's going to give us x minus 2 and x minus 8. If we graph this, in fact, it does cross at +2 and +8, so that those are the roots. And again, if this happens to give us in factored form, so we can do that. Now, if we take a look at the next one and factor it out, notice that this factors because of the difference of squares. It factors to x minus 3x plus 3, and so the intercepts are at -3 and +3. So we know that the axis of symmetry has to go through the center of those two, because those two are the same distance from that. So that gives us a clue as to where the vertex is as well. We can plug that in and find that that will give us a vertex of 0, 9. It opens down, and again it crosses at the two solutions to that quadratic. The last one here we want to take a look at is when we factor out the greatest common factor. Notice we're going to get -3x times x plus x minus 2, and it doesn't quite look in factored form, but imagine that that x is really -0, and so that will give us our two solutions at 0 and 2. And if you think about 0 and 2, then the vertex has to be in between those two along the axis of symmetry. So if we take a look at the table and we graph this, notice that again it does cross through the vertex of 0, 3, and it opens down and it goes through the roots 0 and 2. The last main idea for today is that we have a simple formula that will help us identify what type of solutions we actually have with this. And so the formula is referred to as the discriminant, and those of you that have worked with the quadratic formula before will recognize a little bit of the formula in the b squared minus 4ac. So the a, b, and c come from the standard form coefficients, and if this, when you calculate and use the formula, if this number turns out to be positive, then you have two solutions. If it turns out that this value, it turns out to be exactly equal to 0 when you plug all these numbers in, then you get one solution. That means, again, that the vertex is on the x-axis. And if it ends up being a negative value, this gives you indication that it doesn't cross the x-axis at all. So this is kind of a nice way. Now we refer to it as the discriminant because it discriminates between the three types of parabolas that provide these solutions. So when we look at a standard form, the first thing we want to check out is what are the values a, b, and c. So in this case, in the first one, in number 7, the values for a, b, and c are 1, 5, and 4. So when we calculate the formula and do 5 squared minus 4 times 4, notice we get 25 minus 16, which is a positive 9, which that positive 9 tells us right away that there are two solutions. And if we look at number 8, again, we can identify a, b, and c. We use the formula b squared minus 4ac, and we'll see that this will end up giving us a negative 30. That should be negative 31 actually, but it doesn't matter what the value is. It's still a negative number, so that's the solution. In the next one, you can see that a, b, and c, if we take b squared minus 4ac, this will actually give us 100 minus 100, which is actually equal to 0, and that indicates that there is one solution. So there's a few different values or a few different examples of the discriminant. You just need to plug them in, and the goal is to find out how many there are. You could do examples 10, 11, and 12 here and press pause, and then take a look at them after you have completed them.